Here we go. Good morning. It's Wednesday, May 3rd. Glad to see you back from travels. Susan, how are you feeling today? And what are your expectations?
I'm very happy. The sun is now up at 6 a.m. This is natural light. Happy to be back with you folks and feel like I had a chance to put some focus and energy to some different parts of my life to come back to this little refreshed. And I expect that I'm going to be swept along with your
2002 you published.
Sorry.
And then I've got more to learn. Joe, how are you feeling and what do you expect to get out of today?
I'm feeling okay. I think you've taken all the sun in Arizona because it's pretty cloudy here. So, but
2002 you
I'm
published
excited about
kind of
the
science,
call.
which
As always, it's an honor to be here. And so, today I'm just looking to be surprised, to be quite honest. So I was a little bit late last week to the meeting, and we were going over some interesting things. So it's going to be an interesting exploration. Wayne, how do you feel? And what's your expectation for today?
I feel good this morning. Sunny morning here too. Beautiful sunrise just coming up. So, like you, Joe, I have no idea what to expect. I'm just here to take the ride and just pick any way I can. Susan, it's good to see you back. You do look refreshed, and that's nice to
Yeah, you do.
see you appearing spunky. So welcome back. Steve, how do you feel? What's your expectation this morning?
Well, I'm going to be as surprised as everybody. No, I realized that I had just been really busy this week. And so I just found my notes for today and I have about 40 minutes worth of videos I wanted to watch to find the one that I remember. I've really got to do something more about my filing system, even though you guys tend to think I find stuff just like that. But I mean, I have these epiphanies, and I think I've developed a system for logging those, and I forget to do it. I'm traveling at such a high rate of speed. So I've got what the agenda that's been trailing through for the last little bit. We'll start there. If you guys can think of any good Stephen Wolfram automata videos that show what's going on. I know there was a guy in at Stanford or something with a big beard, and he's talking about consciousness, and he talks about
Robert Sapolsky.
yeah, that's the guy's name, Sapolsky. And there were a couple really short clips from him that focused on Stephen Wolfram's game theory and this automata thing, how you take very small number of elements and put it together with a couple of rules, and how things are totally unpredictable. And it goes from chaos to organization and back to chaos again, just operating on its own, which is, of course, one of the conversations about emergence of consciousness and life and everything like that. So that frustrates me a little bit that I'm not on top of everything like I would like to be, but we have some good stuff left over. I have I had 3 hours and 12 minutes of sleep last night. I still woke up 3 minutes before my alarm, ready for this call. I don't understand that. I'm glad my bodily functions are working, but that's one of the big surprises for me today. Maybe that's why I'm so freaking surprised. So I'm feeling good, and I'm ready to have anybody else guide these days. And I have these epiphanies I wish I were more on top of, so I could do more of what I would think I would like to do, but I'm happy to be exploring. It seems like you guys are all enjoying the conversation along the way. So that's redeeming in and of itself for me, and I'm appreciative of that. So I guess I'm complete, looking for Manu to make it today, and I guess he'll make it when he makes it.
I think we are enjoying it, Steve. I'm still waiting for topology.
Yeah, no kidding. Here comes Manu. Well, this all is about topology. my definition of a working definition for me of topology is topography is a map that shows where the mountains are. And topology is a description that describes what a mountain is.
Yeah, we keep saying that, but if we're having the current conversation and you're saying, oh, this is all about topology, I promise you, I'm not on that page. I don't understand it to that level. And so I'm clueless that that's what we're talking about, and I'd like to know how it relates.
Well,
Yeah.
and
I get the mountain exists and this is what the mountain looks like, but that's as far as I've gone.
I appreciate all the energy you've put into it, and I understand the profundity of the concept.
Yeah.
But I went to visit my boyfriend, and he says, "So what is topology?"
Yeah.
And I stood there. I thought, I can do this, right? I have a limited amount of time, and I didn't get it across.
Here we
I was
are.
like, I saw you a
My
video.
big definition of topology is the donut joke, the coffee cup donut joke. That's what I would show somebody.
No,
That's
but that's what, when you say that to somebody, okay, so I just said, so how a coffee cup and a donut are really the same shape. And
I know it. I'm with you, Susan. And yet I think it's really the key. All right. The human brain perceives reality in such a limited way. We perceive reality in a perfect way to have a human experience.
that's beautifully said.
Yeah.
And I wonder if, and again, I'm going to be catching up with you folks, but you talked about automata and having a little bit of energy and some rules. And so many things you've talked about with fractals, and then heading over to Mandelbrot's set are that you have some rules and a little bit of energy, and you just let the system roll. And this is what you get out of it. And so in some ways, we're looking at fractals, we're looking at essence. And in some ways, that cycling from the donut to the coffee cup and back almost seems like a little GIF segment of that in motion.
Yeah.
And so in some ways, topology is really getting at something much more essential.
Yeah.
Almost like the language of Sanskrit is supposed to be the vibrational essence of the actual thing it's describing.
Yes.
And I don't get too caught up in it. I just kick my feet back and I let that roll over me and let myself experience that. And yet coffee cups and donuts, I'm still in a few knots.
So did you explain to your friend about Sanskrit being vibrationally representative of the thing that's being discussed? Because that's kind of topological.
No, he's
that's what I mean.
like me, Steve. He walked away. Excuse me, Susan. I'm saying he's like me. He walked away thinking he was going to the police station when he started talking about coffee cups and donuts. I mean, boom, I'm in the police station.
We were drinking coffee at the time, but I drink it in really big cups.
Take the lid off and it works. You could say, what's the difference between a donut and this thing? Well, actually, it isn't a donut. It is a donut because I don't know. I want to watch the donut joke again to make sure I got it. So that's great. And Susan, it's a little bit of energy and a couple of rules. It's not
very few rules.
They're just minor things that create all this stuff in life. And so maybe I hope one day to find a good one of those. Manu, how are you feeling today? What do you expect out of the day? We're just getting started.
I feel good.
And you're the last guy. So go ahead and make your statements.
Yes, I'm starting to have some kind of cold, but I think I'm still good. And yes, I want us to continue on the spirit of our previous 3 or 4 discussions.
Yeah.
That is to go a little bit deeper in the meaning of things and try to extract the pertinent and what weighs into helping us to make decisions that embraces the fathers, but at the same time focuses on helping us to face the problems that we have today.
Cool.
So that's what I expect in general from our calls. So you say I was last, right? Yes. I'm sorry again, I was late. but I think there was already a very, very exciting vibe of discussions going on.
Yeah, very cool.
Okay.
You were you were excited about discussions going on in your local area. You had some good discussions going on, or excited about this discussion?
No, this discussion, I heard you and Wayne in particular when I joined the call.
Yeah.
You were discussing about topology, and then Wayne was asking you questions.
Yeah. So
Steve, for me, if I could, maybe
ahead.
this is my expectation long-term of the call, but you know, we transitioned months ago now from real estate to topology and from application of Bucky-in real estate formulas to topology. And I'm still not getting past definitions.
Yeah, me too.
Honestly, the definitions aren't helping me much. I don't want to know what the definition is. I feel a desire to know what it actually is. And like Susan, I want to experience the knowledge of topology. I want to see it, feel it, know it.
Yeah.
Grok it, if you will, in our terms. Okay. So
Good.
I'm just putting that out there, not as a demand, but as maybe a laser guide to get there through all of this somehow. But the sooner we come to that basic understanding, for me, the more all of the rest of it that we're discussing is going to make sense in terms of how it fits into topology. Because right now the conversation we're having is wonderful, but it means nothing to me in terms of topology, because I don't know what that is.
Yeah, well, I think that what these oh good, I found this one that I've been looking for forever. This one is a little bit about topology, and it's a little bit about imaginary numbers, and basically it goes along with what you're saying, Wayne. These things I'm showing you deal with the reality and the application of topology and imaginary numbers, and somehow the definitions underlie it. And like I said, I'm ready to have somebody just snatch up the agenda for a couple of weeks and let me stew on it. But let me also bring up a couple of points here relative to what we've all just said. This video right here is it's 5 minutes long, but it shows the 3D application of imaginary numbers. Because right now what we see is we see imaginary numbers on a XY axis. So the X-axis is real numbers, and the Y-axis, the vertical axis, is imaginary numbers. And as you're seeing in this guy here, it shows the hyperbola, these little guys. I'll just play this, and then we'll go back to imaginary. Then we'll go back to Mandelbrot set. But here's a really cool depiction of imaginary numbers, which represent a 3D reality. Here we go. Let's see if this. I just found this today. I've been looking all over.
Out where the equation equals.
Hang on, I want to make sure that you guys have the audio, and I'm not sure I have the audio plugged in. I think
I was hearing it.
good. I think that I think that Zoom did a change, so you don't have to click that share sound button anymore. But I like to click it and make sure. Here we go.
Let's say we're given the function f of x is equal to x squared plus 1. We can graph our function and get a nice parabola. Now, let's say we want to figure out where the equation equals 0. We want to find the roots. On our plot, this should be where the function crosses the x-axis. As we can see, our parabola actually never crosses the x-axis, so according to our plot, there are no solutions to the equation x squared plus 1 is equal to 0. But there's a small problem. A little over 200 years ago, a smart guy named Gauss proved that every polynomial equation of degree n has exactly n roots. Our polynomial has a highest power or degree of 2, so we should have 2 roots. And Gauss's discovery is not just some random rule. Today we call it the fundamental theorem of algebra. So our plot seems to disagree with something so important, it's called the fundamental theorem of algebra, which might be a problem. What Gauss is telling us here is that there are 2 perfectly good values of x that we could plug into our function and get 0 out. Where could...
Okay, so I think you guys, when we remember the video on the history of imaginary numbers by the Vertasium guy, Derek, the Vertasium guy, he talks about two solutions to a problem. And Manu has talked about this as well and can reaffirm it, that that there are always two solutions of a problem. One regards a negative number and the other regards as complementary positive number. I think I said that right, Manu, that there's a solution to that every formula has a solution with a minus number and a plus number in it to some degree. We'll see how this rolls out right here.
Could these two missing roots be? The short answer here is that we don't have enough numbers. We typically think of numbers existing on a one-dimensional continuum, the number line. All our friends are here. 0, 1, negative numbers, fractions, and even irrational numbers like root 2 show up. But this system is incomplete. And our missing numbers are not just further left or right, they live in a whole new dimension. Algebraically, this new dimension has everything to do with a problem that was considered impossible for over 2,000 years. The square root of negative 1.
The square root of negative 1. So I want to show that again, because there it is. There's the x-axis, which represents real numbers, and the y-axis, which represents imaginary numbers. And he's going to show us how there's two solutions for every problem.
Of negative 1. When we include this missing dimension in our analysis, our parabola gets way more interesting. Now
that blew my mind.
Cool.
Does
Well, he
that blow
said it
your
exists
mind?
in a different dimension, and he just lifted it into a 3D perspective.
Exactly. Any expression of imaginary numbers is a 2D expression of a 3D reality. And he just took
that's great.
What's that, Susan?
That's great. That's a very important little standalone statement that might help move this train forward.
I
Your
agree.
mic isn't very loud, Susan. I don't know if we can adjust that.
That's just a huge statement that, Wayne, you and I really want to get to understanding that, be able to define experience topology. That statement's probably really important.
You would think, yeah.
I totally agree. So let me say again what this says. When this guy starts his video, he says you see this red hyperbola there, and the premise is that there has to be a real solution, and that thing does not cross the x-axis. Therefore, it stays in imaginary realm and doesn't affect reality. And the way they demonstrated is that Gauss said that every formula has to have the two solutions. And as soon as I move it into a 3D reality, that red hyperbola there starts changing colors based on the how much I move along the x-axis, to where at some point it does cross the x-axis. So cool. I'm ready to back up that minute and a half and have everybody watch it again, because this I tried to find this a couple weeks ago and couldn't find it, and it appeared today. So
I don't need to watch it again. I got it, but if you want to back it up for another reason, go ahead.
okay.
So, Steve,
Can I,
Actually,
can I say something?
Yeah, we have 3 people who want to share. Let's start with
Okay,
Susan.
so I would like to be the last one to share.
Okay, good. We'll start with Susan. We'll go to Joe, and we'll go to Manu.
that really big statement that we just had, that any expression of imaginary numbers is a 2D expression of a 3D reality. Does that mean that in some ways it is actually a derivative? Is that a fair way to characterize that?
Makes sense to me. What do you think, Manu?
No, I'd like to hear Joe first, and then because
no, I was just actually, it was almost exactly along those lines. I was actually just going to ask to replay the video a little bit, but that I do want to hear the answer to this, because I think this will be very helpful.
It's only a minute and a half, so let's
Well, no,
watch.
I only need the last 10 seconds, like, or 20 seconds.
Let's hear Manu, because I think he's probably going to shine a big light right here.
I think he is too.
Okay, Manu, go for it.
okay, I would like to talk, I really have a very simple view of this. Very simple. I don't know if I expressed it a few weeks ago. I don't know if you got me. And I think it's very, very simple. The very first thing is, what is the fundamental principle? The fundamental principle is that of
Gauss?
Oh,
The
please.
fundamental principle is that of duality.
Oh,
Yes, yes, X and
Let's
Y,
go from that.
X and
okay.
Y.
Right. Now, the dual of anything is not the opposite. It's always coming at 90 degrees of a thing.
Right.
Let me repeat it. The dual of anything is not the opposite. It is at 90 degrees of that thing.
and
Because it
coincidentally,
derived precessionally from a rotation.
Thank you. Yes, this makes sense.
Okay, let's just say, do we agree to that second thing?
Look,
Yeah,
yeah,
but here-
I do, I think, let me ask a question though. Is concave convex also at 90 degrees?
yeah.
Yes.
Okay,
Yeah.
all right, that makes sense then.
And this little graph right here, we took the x-axis and we extended it at 90 degrees to the y-axis.
Exactly.
Okay.
Degrees
Which
right there.
lifted it into
And
3D.
Steve, if you see the way your picture, this picture came, there was a rotation. If you watch
Yeah,
the 1 minute 45 seconds, you will see how it rotates. And
Yeah.
then that grid comes on it.
well, let's
Okay, but
watch.
I don't want to complicate it. So if we agree on those two things.
Someday I will take mushrooms, Manu, and I will see this without all the
Okay, I
Okay.
think it's important to watch the minute and a half again, just to establish your point, Manu.
Okay, you can look at it if you want.
Let's watch it for a minute and a half, then we'll pause and let you continue.
f of x is equal to x squared plus 1. We can graph our function and get a nice parabola. Now, let's say we want to figure out where the equation equals 0. We want to find the roots. On our plot, this should be where the function crosses the x-axis. As we can see, our parabola actually never crosses the x-axis, so according to our plot, there are no solutions to the equation x squared plus 1 is equal to 0. But there's a small problem. A little over 200 years ago, a smart guy named Gauss proved that every polynomial equation of degree n has exactly n roots. Our polynomial has a highest power or degree of
Sorry.
What happened?
2, so we should have 2 roots. And Gauss's discovery is not just some random rule. Today we call it the fundamental theorem of algebra. So our plot seems to disagree with something so important, it's called the fundamental theorem of algebra, which might
Those are
be a
buffering,
problem.
and I'm sorry.
What Gauss is telling us here is that there are 2 perfectly good values of x that we could plug into our function and get 0 out. Where could these 2 missing roots be? The short answer here is that we don't have enough numbers. We typically think of numbers existing on a one-dimensional continuum, the number line. All our friends are here, 0, 1, negative numbers, fractions, and even irrational numbers.
What, Manu?
Start watching, pay attention.
Yeah, okay.
The short answer here is that we don't have enough numbers. We typically think of numbers existing on a one-dimensional continuum, the number line.
Axis.
All our friends are here, 0, 1, negative numbers, fractions, and even irrational numbers like root 2 show up. But this system is incomplete. And our missing numbers are not just further left or right, they live in a whole new dimension. Algebraically, this new dimension has everything to do with a problem that was considered impossible for over 2,000 years, the square root of -1. When we include this missing dimension in our analysis, our parabola gets way more interesting. Now that our input numbers are in their full two-dimensional form, we can see how our function x squared plus 1 really behaves. Our function does cross the x-axis. We were just looking in the wrong dimension. So why is this extra dimension that numbers possess not common knowledge? Part of the reason is that it has been given a terrible, terrible name. A name that suggests that these numbers aren't even real. In fact, Gauss himself had something to say about this naming convention.
I guess the guy's not going to read it. I want to read it. That this subject, imaginary numbers, has hitherto been surrounded by mysterious obscurity is to be attributed largely to an ill-adapted notion. If, for example, +1, -1, and the square root of -1 had been called direct, inverse, and lateral units instead of positive and negative, and imaginary or even impossible, such an obscurity would have been out of the question. In other words, here's your convex and concave. We're talking about inverse and lateral. Instead
Okay,
of,
but-
He
Go ahead.
was a smart guy.
okay. So you saw the way it proceeded. First, we have an axis like this. The plane was like that, vertical. Then he did this, horizontal, and he turned it 90 degrees, and he pulled out the string.
the x-axis gets extended.
Yes, what I'm saying is that what we were seeing on the screen was initially like my book here.
Yeah,
Then he did this. If you look at the way it was going, he did this. Watch again later.
Went
he did
flat.
this,
Two-dimensional.
turn it like that, and then showed the x,
Go
the
three-
y dimension perpendicular to that plane,
well, actually it showed the,
pulling that grill out.
actually it showed the x dimension perpendicular up from the y dimension, which is now flat.
Okay, right. So,
Okay. And this is
okay.
dimensional compression, which scientists and physicists use constantly in order to, if you want to see a fifth dimension element, you take the other 4 dimensions and compress them onto a 2-dimensional plane, and then you can see the third, that next dimension stick up. They do that. They do that. all the
Steve, I
time.
want to
Carl
debunk.
Sagan actually does.
I
what he
want to
does.
debunk the dimension and the imaginary. We already agree on 2 things. We agreed on 2 things, that there is duality and that the dual is somewhat at 90 degrees to the other. They are 90 degrees to each other. The third thing that I want to clear here is that when you talk about dimension, it's only the kink of a surface from where you are observing. Let me repeat it. The polynomial of dimension n is the number of angles, is the number of roughness of if I take a surface, if I take this surface, dimension 0. Look at this, or dimension 1 if you want. If I do this, I'm adding a dimension.
Right.
I've curved it. If I do this,
You folded it. It folds.
yes, I'm folding. If I do this, I'm adding another dimension. If I do this, look well, I'm adding another dimension. If I do that, I'm adding another. All of this complicate in terms of what angle am I turning again in order to describe the thing. In the end, I have a polynomial like this. This is a polynomial.
Mhm.
So yes, our
Okay, so I want to do. here's-
So that's why God say, for each polynomial equation, there are as many solutions as the number of corners. That n is the number of corners of a polynomial. So if I take my stuff here, my isocosahedron here, these are the n dimensions. So my isocosahedron is of 1, 2, 3, 4, 5, 6, 12 dimensions. There's 6 here and 6 there. You see that?
Yes.
Also the 12 degrees of freedom.
Okay, I want to do what Manu did about folding for dimensions. Here's 1 dimension. Then
Yes,
we fold it or have a perturbation. And now I have 2 dimensions.
yes.
Now I can fold it again and create a 3rd dimension. My problem is I've got to rip it to do it. And it shouldn't be ripping, it should be folding. There's 1 dimension, there's 2 dimension, and now there's 3
It
dimensions.
fall on it, yes.
Because
Yes,
it simply folds on itself. Dimensions are created by folding, by perturbing space and folding it.
okay.
1 dimension,
So
2 dimensions, 3 dimensions.
So is that clear? So that is the third point on which we are clear. Are we all clear on that?
Yeah.
Well, when you say that is, which of all the things you said is the that you're referring to?
The first was the duality.
Right.
We agree that there's always duality, it's general principle.
In other words, the thing always has something at 90 degrees to it.
So when you say, is that clear? Are you saying, is the duality of it clear? Is that what you're asking?
Do we agree to it? Because I'm building on something.
That
Do we-
duality occurs at 90 degrees.
No, we say the
Well,
first
let-
thing is that the
let-
general
let-
principle
Let him
is the
answer my
principle
question.
of duality. Is a generalized principle. Are we in agreement to that?
Okay, one more time. I need to understand your question. And I'd like you to answer, Manu, or you to explain it to me, because this was your point. So go ahead, please. What exactly are you asking me if I agree to? One more time, please.
Have you understood that the duality is a basic general principle?
Yes, I understand that. Thank
Okay.
you. And
Second,
just as a point, guys, I've found, especially in writing, when I use it and that and they and them, it's very obscure because I might know what I'm thinking of, but
Nobody else does.
the other
This
brains
is
might
called,
not.
this is called the
Okay.
antecedent. This is called the pronoun of the antecedent of the pronoun. So
Yes.
stop using the its and that's and talk about what it is, even if it have to repeat language. Go ahead.
okay. Secondly, we agreed that adding a dimension occur at 90 degrees.
Yes.
And I want to make a point on this. The tetrahedron is an example of 4 90-degree realities that are expressed in a 3D reality. By compressing
Okay.
the 4 90 degrees to 60 degrees, we can actually conceptualize a 4-dimensional reality in 3D,
Okay.
right,
So-
Wayne?
Yes.
So in order to, what I need to do to understand a tetrahedron is take those 60-degree angles and make them all 90 degrees.
What I just saw, I think, and it's really exciting, and I am answering your question, Steve,
Thank you.
is we do the first fold and that puts us at the 90 degrees and that gives us duality. But the other more complicated and complex folds from there actually begin to take effect because of torque and rotation and twist and turn. It's not a singular direction. It becomes a spiraling thing. What's fascinating to me about that, because it activates something in my thinking that has popped up over and over again in these conversations. I'm really seeing, almost, not to the point I could describe it or prove it, I'm seeing how our choices draw that out, create that, invoke that, shape that reality. And that our choices, as they all interact together, are part of that torquing, twisting, folding, emerging.
And you say a very important word. And you say shape.
Mm-hmm.
Because all we see is always shape. Remember that we fold to close because we see a bundle of energy in a shape. We fold to close. So we have that. The third thing, which is a consequence to this, is that, okay, let me just put a
Hold on
note.
just a second, Manu, before you go on. I think Susan had a comment.
It's more of a question because I think what Wayne just brought up to add on to what Manu was doing was this perspective of the observer moment. So Manu, you just said that the duality is generalized and it's occurring at 90 degrees. So I, as an observer, I'm in one plane. I see that this is unfolding. And so I, as the observer, move in my perspective. And I think what Steve just expressed very nicely is that 4D reality, in order to hold it in the pieces that I own in this brain, I've compressed those 90-degree angles to 60 in my perspective, from my perspective. And even though I can take on faith and additive experiences that these are expanding at 90 degrees from each other, once I get over 4 dimensions, those angles at which my brain has to fold in, has to derive a perception, start narrowing those angles down, they start to get very tight, and they're much less easy for me as the local observer to remember that they're happening at 90 degrees. Is that fair?
I would say it's fair.
Yeah, it's fair. This is the reason. Again, I put a link in there to Hopf Fibration. Everybody talks about spiraling. It's not just spiraling. It's like what Wayne said. It's torquing, spiraling, spinning, orbiting all simultaneously. So, and the brain can't see that. The Hopf Fibration video shows that precession that Bucky described in his six little, in his torque, spin, orbit, expansion, inspansion, or compression. He called it compression. I call it.
Okay, can I?
Joe had something, Manu, before we go to number 3, if you will, please.
No, I was just going through the number of solutions that are equal to the number of corners that possible solutions to a potential problem. Are those decisions? Could we use the same thing as the idea of a decision when you're talking about the number of?
A solution is when the equation is equal to 0. That's what we call solution.
But I
Or
think you'd ask,
equilibrium.
Joe, are you asking if the corners could also represent decisions? If
Yes, that's what I'm saying.
What do you think?
Could
Manu?
they represent?
They represent folds in reality, that's for sure.
Yeah.
Remember in Gauss's formula, it's function of x equals x squared plus 1. And the square says there are 2 dimensions to this thing. So there must be 2 solutions. There are 2 ends because the power on the equation. So if we had f of x equals 3x plus 1, there would be now an additional dimension to examine. There'd be a new n. And when Manu says this has 4 ends, we're talking an expression of x to the power of 4. If he's going to describe every one of these corners,
Say
by
ends or corners, Steve?
what he says corners, Manu said,
But you said ends. I'm asking you, are those corollaries?
yeah, I'm saying there must be some correlation between ends and corners.
No, I think n describes the number of corners, and I love. So, and again, I know I'm always the naughty mind in the group, but and Manu said the word kink, and then he said the roughness, and all of a sudden it's freaking topology. We're talking about the roughness.
Yes.
It is the vertexes, the corners. That's what it is.
And that number
So
of corners
yes, is a
right
number
there.
of turns, a dimension of something. Another definition of it is a number of turns that you take before you close.
Number
The
of 4.
minimum number of turns that you take to close. That's another
4.
definition of dimensions.
So isn't the word fold a synonym for turn?
Yes. So how many turns do you take to arrive at your destination, going from one direction and coming back from another? That define the number of turns or corners of your polygon. This is a polygon.
That sounds like both topography and topology. I'm thinking a meets and bounds survey. 30 degrees this direction for this much, and then it turns 5 degrees the other direction for this much, and back to the point of beginning. And now we're talking about a boundary.
Right,
Yes.
but the topography is the how much. The topology is the degrees of turns.
Are the
Yes.
angles? Are the angles?
of the-
Angular momentum.
It's starting to gel. I don't know how long I can hold it, but it's
Okay.
starting to-
But a
Right.
meets and bounds description captures both. One is the
Both.
physical boundary and the other is the math of it.
I
because
wanted to get to something before, because it's very exciting and we can easily go many directions. So if we hold those 2 things, the comment that I make is that any change of dimension, we see it is always at 90 degrees. That's why the derivative is a 90 degree of a function. You get me?
Yes,
Any derivative is at 90 degrees of a function.
X and Y.
Well, X and Y are two. Y is a derivative of X.
Now, if I take the derivative of x squared, it is x, right? That's the derivative of x squared. And x squared are perpendicular.
Okay, so hold on, guys. You lost me with the word derivative, and it came up earlier in the conversation. I left it tabled, but I want to understand it. How is Y a derivative of X?
Okay, a derivative means a division.
Comes out from.
Yeah, it comes out from. Remember in that video, the guy grabbed the x-axis and pulled it up?
Mm-hmm.
But how do you come out of something, Wayne? If something has a shape, how do you come out of something? How does the baby come out of mommy's womb?
At 90 degrees.
At 90 degrees of the surface of a uterus. When I pull out anything, if I pull out something from a jar, it comes out at 90 degrees.
Well,
I don't pull it out
theoretically,
on the side.
it could come out at any other
It comes
number.
out at 90 degrees of the shape of a jar, always.
But it not always. I can pull a pickle out on an angle. It can come out on any degree up to 180.
But
No,
it
but
was-
the act of pulling out, you show
But
me
it
how
was-
it doesn't come out at 90 degrees.
But-
Just tell me
but-
how.
But Wayne, you may have pulled it out at a different angle, but that angle you pulled it out at is at 90 degrees to something.
It's on 90 degrees to the pickle.
There you go.
Okay.
And this
It's
is
always.
brain. This is why the tetrahedron at 60-degree angles is a representative 4D reality. I have to take those
Okay.
things when I see a tetrahedron. I don't see those 60 degrees. I see 90 degrees.
Okay, the second
I'm
thing
not
that I
done
want
with
comment
yet.
that I wanted to
Stop,
make.
Manu. Hold that one, please. Go ahead, Manu, please.
The second comment, this is the comment, I haven't gone to the third point, is that you always see at a knockdown degree of a reality that you are seeing. In other words, if something is at degree 4, you only see degree 3. If it's degree 5, you only see degree 4. You always knock out something because you are looking in one direction. That is a referential. By looking in one direction, it means that one of those poles, you have fixed it in order to look at the direction. Because there's no direction without fixing point, without the original point. You understand my point?
I wanted to say what Manu just said with different words when you're ready.
I don't understand your point. No.
Okay.
But let me
When-
say what you just said, Manu, with a little different thing. If I
Yes.
draw a 1-degree line to you and you see a 1-degree line, the only reason why you can see the 1-degree line, that line, is because it's existing in a context of 2 dimensions. Because a 1-dimensional line has no thickness whatsoever. And for me to represent that 1 dimension to you, I have to put it in 2 dimensions.
And the other thing that I think is important here that Manu just said is that a referential is talking about the location of the observer and which way is the observer looking.
Right.
And so if I'm looking, and again, my brain tries to collapse it all into 2D or some lesser dimension than it really is. But if I'm looking in one dimension, Wayne, I am the event horizon. So concave is here, convex is back there,
Okay.
because I am the event horizon as the referential observer.
But what I'm
Okay.
seeing, excuse me, go ahead, Susan, please.
Now I'm asking Manu if so far I have messed it up.
Yeah, I'll get it. No, you haven't messed up. And let me put it
Please don't.
for Wayne to get it clear.
Yeah, let me say something, Manu. We've got to go slow here, baby steps for me at least, please. And I know you're anxious to share it. I'm anxious to hear it, but I also want to understand it. So Susan, what you just said, I am the event horizon, concave, convex. And wherever I turn and face is what I'm hearing Manu say. determines the angle and what I end up experiencing as reality. Doesn't that go to the heart of what I was saying about choice and my energy and my reference? And I mean, we are the creators of our own reality just by turning and looking a different direction, even. Or
Exactly.
looking at it from a different perspective. Go ahead, please, Manu.
Yeah, because when you say that, I'll just take it from what you say, Wayne. How many items did you say? You say concave, convex, and event horizon,
Mhm.
I just,
right?
The boundary between those two, yeah.
Yes, in order to say convex or concave, you have to turn. I'm an event horizon, I have to choose. So I fix the event horizon. Unity is plural, not at a minimum of 2, but at a minimum of 3.
If you include yourself.
Oh, yes.
here we go.
Okay, so
Buckle up.
this is critical. If I show you a one-dimensional line, you will not see it unless you conceive of that line, that one dimensionality in a two-dimensional reality, because there has to be a width in order for you to see it. This, everybody agrees, is it could represent a two-dimensional plane as long as that is infinitely small. And the only reason you would see the two-dimensional plane is if I rotated it up. And I've got to be in 3 dimensions to rotate it up. So the only way that I can conceive a two-dimensional plane is in a 3D reality. Now, we live in a 3D reality. The only way we can perceive a 3D reality is we live in 4D, but we don't see the 4th dimension. It's the ocean in which 2D reality exists.
Is that the same thing as what Manu said a minute ago?
Yes.
You're always
Let me
perceiving
explain again.
one
You
dimension.
have a line. This is a line like this. And Steve said the only way you can see it is if you are in 2 dimensions. But now, which is the point of this line that is on the 2 dimension, on the 2nd dimension? Which is it?
I thought he said the only way.
I'll give you $5 if anybody tells me that. $5. I'm serious.
What's the question? Are these South African dollars? What are they worth?
It's worth a lot in South Africa. $5 is worth a lot. Okay. The only point that is the origin where you are, is where the 2nd dimension is cutting at a point on your thing.
Folds.
That's where you choose, you call it origin. You see, we put X here, we put origin, and we look that direction, we say positive direction, we look that direction, we say negative direction.
So it's my
Another
reference
example
point.
that is potent, if you want to watch a soccer game or what is baseball in the US that is popular, you come into the arena, don't you choose a position to maximize your view? Now, when you are choosing a position, what have you done? In terms of observation, you have fixed one point. You knock out a dimension. Now, if we agree to that, let me go further to tell what you call polarity. Because for me to observe in the real world, I need to fix a point. I call a pole of my observation. But I know that there's duality. So there's a convex part that also has a pole. Therefore, you have the 2 of anything that forms the axis. So that's the 2 that you find in the Euler identity, right? That's the number of vertices plus the number of faces minus the number of edges is always equal to for any polyhedron. This is a powerful identity. You remember that?
Yeah. Manu, can I interrupt you for a minute? Because I'm having an experience about this as we're talking about it. I'm looking at your image on the screen. I have the sun shining at sunrise on my left cheek. you appear to have the sun shining, I presume at sunset on your right
Yes.
cheek.
Yes, it's afternoon here.
How is the sun shining in both of our areas when we're so, where are we on the planet that we're getting both of these at the same time? I am
We are
one
two
event
polarities.
horizon, you are the other event horizon, but I'm seeing both on video.
But
You missed
understand
the point
also
of
that
reference.
Manu's video is warped, so you're seeing it backwards. His sun is over there on his left shoulder. It's actually on his right shoulder,
Yes.
I think.
Yes, my
Because
son
he
is on
needs
my
to turn
right
his
shoulder.
video.
Yeah, that's what I
My
said.
son is here.
That's
Yeah.
what I said.
Yours
It's on
is
my
on the
left,
left.
his right.
Yes.
Okay.
But we're so used to that, it is what we see. So that was my second point. The third point now that comes to, because we were turning, remember we're watching the sun. And that sun is one sun, the reality. I was watching the sun here, you're watching the sun where you are. Right? Now,
It's watching me.
yeah. So the way I watch the sun now is that because there is a turn, there's a part of the sun that I don't see. I'm in a phase. I'm in my real phase. Let me repeat it. When I'm looking from my referential at an object, I can see only a phase of the object. But I know that the object exists because it has repeatedly come to me. The sun has always, right, in and out. From experience, it's always been. So therefore, there must be part of the sun that I don't see. And for me to represent my whole sun, again, I have to take a referential. So I squash my experience, that is sensorial, to what I call real. That relatively is a line. I squash everything. That 4 dimension that Steve was talking about, put it there. But I imagine that I know that the other one exists. The other one is hidden from me. And it is, I call it imaginary because it's hidden at this time for me. And it's imaginary and it intersects with my line of experience here at 0. It projects at 0 because it doesn't give me, a projection gives you information on something. When what you see of me is just a projection of me, isn't it? It's projection of light on me, the light beam on me, that's reflected and captured and transmitted onto a screen. That's what the camera is doing.
Yeah, I just pulled up a 3D globe on my phone. And what I didn't understand until this moment, I don't know how many miles away, if somebody wants to look it up quickly, Cape Town and Salt Lake City are, but I would imagine about half the globe, probably 10,000 miles.
Yes.
Way I'm seeing it.
Yes.
And what I didn't understand is that there is almost nothing but ocean between us. If you go up on an angle from down under up to a northwesterly direction, you'll run right into Florida and come up over onto the Rocky Mountains. And somewhere that sun is 93 million miles up in the sky right now, shining down angularly on both our homes.
You understood? I have the experience of the sun. You have the experience of the sun. It's not the same experience.
Right.
Yours is hidden from me.
Right.
You, Wayne, on my understanding, you are imaginary to me.
Mm-hmm. They call that a
Proof
nightmare.
that it's morning to you while it's almost dusk to me. You get what I'm trying to say?
Yes.
So the whole, that is the complex whole, is always a combination of Manu's experience plus Wayne's experience. Because I know that if I give you the description of the sun, my sun experience today, and you give yours at the same time, and I'm seeing our 2 is going to be a complete description of the perception of the sun from this planet Earth as this time. Does it make sense?
Yes, yes, it does.
That's why it is called imaginary. Imaginary is nothing that is mystical. It is nothing that is invented. It's something that exists as part of a whole that we are considering, but that we cannot see in our real experience today. So it will come. For convenience, we say square root of 4 is 2, but we know that square root of 4 is not 2. It is 2 and minus 2, because 4 is 2 squared, so it's twofold. And Euler and Gauss' demonstration was that the number of solution of any polynomial, this means polyturn, polycurve, polycurve. That's what polynomial means. Something polycurve is a polynomial.
Polycurved?
Polycurved, yes. Polycurved to folding, to
Polycurve.
closing.
Yeah.
A polynomial, let me just give another thing that I think a polynomial is. It is something that you take, you fold it many ways in a way that it closes. Because a polynomial should always determine a volume inside and a volume outside.
Ooh, there we go.
It closes. That's why we talk of spheres. That's why we talk of this is a polynomial. A tetrahedron is the polynomial of dimension 4.
So Manu, isn't what I call my reality then a polynomial? Because it closes based on my perception and the boundaries that I put on it with my perception and my choices, conscious or not.
You might say it's yours, but it's also mine, because we are prisoners of that. We are
Right.
in that.
But we just, well, everyone's is, but we just said that our polynomial of the sunset is different from one from another.
Yeah, but the polynomial from Earth is the same. Me, I and you is the same, because we are inside.
So Wayne, what you're hitting at, I think, is this mind-brain difference. So your brain sitting in Salt Lake City has your local experience, right? You would need to shift into mind to take your perspective out of Salt Lake City, take it out beyond the sun to watch the sun hitting the globe.
Mm-hmm.
And so this is where humans are so absurd and sublime. We are absurd because we insist upon this singular, my singular perspective and reality. And we stomp around like 3D is the only reality that matters. And that's what we're going to prove in a court of law and
Yeah.
science. And we'll fuck that because we're 4-dimensional beings having a spiritual experience here, but we're denying our at least 4 dimensions, if not all the higher dimensions. And we
Okay.
walk around like talking about that is mystical bullshit and libelous. Couldn't be further from the truth.
Excellent. Wayne, you see this, right?
I do.
I am here near to this pole here. I'm here.
Okay.
You are here next to that pole. We still in the same tetrahedron. Right? So
We are,
polyhedron.
I think in the nested reality, Manu, we're both in our own and within the larger one.
No, you think in your own, because thinking is divided. So when you divide, if I decide to divide this thing, you are here, I divide it like that. Sure, it's going to be different from mine. Dividing from this, considering from here, is different from mine. But the fact that it's different because I've divided doesn't change the reality. I love that.
You know what these are?
I love that.
You know what these are,
Yes,
right?
yes, I love it. You
So-
can do whatever you want, but it is the same stuff, right?
Yeah,
The whole is the same. The whole doesn't change.
but this is going on invisibly inside of that tetrahedra.
Exactly.
Okay.
So the sun, remember that the sun for us, the experience of the sun is outside of this tetrahedron of Earth now, is outside of it. So whatever you do, we're gonna have each partial. We can distribute ourselves inside in such a way that we grossly have all the information on the sun from the perspective of each of these, right? If we had somebody in New Zealand, another one in Japan, you in the US, I'm in South Africa, somebody in Europe, and somebody in the Pacific Islands, all of these things, we will surely have later, with like description of the activity of the sun on Earth today.
Yes.
Because we are able now to put it together, to put back together. Notice that the notion of derivation is a particular point of view of experience of something whole.
That I get. Did you understand my comment was really kind of a question? Let me ask it again in a different way. Do you agree that when you hold up your tetrahedron and say, you're here, I'm here, but we're in the same tetrahedron, do you also agree that, yes, that is one perspective, but I also have my own little tetrahedra going out of my perceived reality where I am right now locally?
I agree 150%, otherwise we will be dead.
Okay.
Because since everything is moving and we are inside and we want to preserve our entity as individual inside, we always have to position. Otherwise, we're going to be warped, or we're going to be twisted, or we're going to be killed. You always have to have a different perspective in order for you to align with the currents of flow of energy within that in a way that preserve you and in a way that you prepare easiness forward. That's what you called yesterday abundance. Abundance is easiness forward.
Mm-hmm. One of the ways that the book Cosmometry expanded my thinking while I was in Colorado is when I started really study the torus and the movement of the energy in the pattern of tori that is universal. It's everywhere. It's in everything. That's how energy moves, in that in and out and spiral and circling and whatever words you want to put on it. I started to see this image of my little tori above the bigger one and the little funnel of the concentration of energy spinning down and becoming causal in the bigger one. And I drew a diagram of that. And then the next morning I had this huge aha in my meditations that no, it's not your little one dumping into the big one. It's all nested. It's all overlapping, interposed, interconnected, interfluid, if you will. And that was such a mind stretch because I could not think that thought three-dimensionally. It's impossible. I couldn't think, it doesn't fit. So I had to somehow get to 4 dimensions and just sense, purely sense and sort of trust the image I was getting as opposed to seeing it or even thinking it. And then it began to make sense. They're this all moving and together and in and out of each other, and reality as we perceive it constantly shifting. And yeah, this little thing that is me has some causal effect in that along with everybody else, and out comes the history of the whole thing, if you will. So
beautiful. When you are thinking, you want to be on an orbit away from the core of your torus. Because it's a long way. You're resting, you're dreaming, for example, is a long wave that gives you the relative impression of being an observer of a whole. That's what the dream is.
Right.
But when you are doing, you want to be as sharp as you are in the axis. You see, when the torus does this, it goes and then come here.
Focused, pinpointed.
The velocity of the wave in the core is not the same as away from the core.
Right.
You understand? So this is now you, the micro, positioning yourself, in regard to reality around you, to maximize your position and what you're doing. When you want to rest, when you want to rest, for example, every day, you really want to rest in the optimal conditions. But when you want to act, you want to be incisive. You want to be incisive to realize the thing because you know the rules. So to me, this I went here to just say that this imaginary, people have been saying a lot of things around this, but imaginary, as God said, is not complex. You call it complex numbers because there is what we sense, we see directly, physically, and what is out of reach of our senses momentarily in terms of experiences, the experience that we are living. But it will come with lack. That's why the lack is so important. It's not some magic. It will come. So 2, in other words, in the word of the tetrahedron, the 2 becomes the -2 all the time. It's just that they don't appear at the same time. That's why we see only 1.
Concave, convex.
It's concave, convex all the time. It's exchanging, it's dual.
Jitterbug.
Yes. So you've seen. You can even actually say that the notion of continuum is a fake notion. It's not true in terms of experience. The continuum is always something like you have stars, and then you have dimness in between. But the relative speeds of observation and reality give the impression. We in other words, we are watching shades of things.
Yes, in cosmometry, they explain that this square panel here, you have 3 of those top, 3 of those bottom. Right here is where it happens. This plane flutters in and out. It collapses in and out, open, closed, open, closed. And in that fluttering right there, which I believe is what Bucky referred to as the jitterbug, is where what we perceive as tangible reality takes place. This is where unseen, imaginary energy, if we continue to use that word, becomes the thing that we see as matter and tangible, our own
And
reality.
you say something very important.
That's where it happens.
The square. You know why the square? You know why the square is so important?
No, I don't.
Because the square is not stable.
Yeah.
The
Okay.
square is the one that twists
So that's why it
to
collapses.
allow the folding and unfolding,
Okay.
to allow, to restrict, or to allow maximum energy passing.
There you go.
That's the magic of it. It's a combination of lozenges and triangles
Mm-hmm.
to give the maximum flexibility of everything. That's it. It turns, it twists. You see that?
Yeah.
And all of this is compressing or restricting energy or opening.
10
And
seg,
Bucky called it basic pumping.
and there's tensegrity in action.
Yes, that's it. That's why Becky wants us to be sensorial, understand what is going on. Because it twists and turns, and therefore hides. Anything that twists and turns hides some part of it, true or false.
Yes, at some point, half of it is not visible.
Yeah,
At every point,
or part of it. So it's
part of it, some part of it
if
is
you
not
want to
visible.
describe it, you have to describe in the plane that I see, in the part that I don't see.
Mhm.
And the part that don't see always project as 0 to the part that I see. That's why I say imaginary. I say imagine. It projects as 0. If you study mathematics, in actual fact, derivatives, integration, and the imaginary numbers have the equivalent in algebra in terms of what you call projections. If you study what they call multidimensional projection, that's what it is. That is shades, the theory of shades. What do you see? What shade do you see of reality? Because we know that we are inside, we are unable to describe the full reality through our experience at all times.
Yes. I think
Okay,
Joe
I'm
might be
through.
drawn to this thought.
I hope it helped.
It does. I'd like to make a different application of it if I could. Joe, one of the things I appreciate about you is you're constantly seeing this, it seems to me, in terms of behavioral aspects, in
I
terms
am.
of the organization.
I am. I'm seeing it in behavioral, and I mean there's a couple of aha moments that I'm actually having, right? Specifically the referential. So it basically is our frame of reference. And yes, that does like kind of relate to organizational behavior and things along those lines. But it's basically describing all the things that how we interact with the world, meaning motion, time and space, and it does relate to choice within that framework. So if you take all those things and you think about it, that's the perspective an individual has on reality. So the understanding that you're not seeing the whole is actually an important part, but the reference point of the observer, this is just being expressed in mathematics, impacts our decision making overall.
Yes.
And so when you get into the ideas of things like physics, this all matters, right? And there was a documentary on time called Closer to Truth. It talks about the idea of taking a picture, a snapshot, how the distinction is between what you're taking a snapshot of and what you're actually observing. It's a point in time that you're capturing. This all has actually very, very important decisions, or important factors too, when you're talking about how to optimize something, how to optimize a decision within a frame. So the most important part I'm taking away actually is the idea of how imaginary numbers factor into this.
Well, the unseen portion, right?
Yes, the unseen, how that relates to the unseen. And this can, and then slowly but surely, you can start to see these structures actually starting to work together. Specifically how concave and convex, actually, you can start to see how they relate as well. As well as the tetrahedron, what you were just talking about briefly. So
What
how?
Go
Okay,
ahead.
Jan.
Go ahead and finish.
No. We can come back to that, how 4 dimensions relate to the 3 dimensions,
And maybe this will be a stepping stone
with
to.
the tetrahedron.
I thought you would appreciate this part of it and maybe have something to add to it because of your behavioral, the training you have in behavioral sciences as they apply to organizations, at least in a business way, as a consultant. I have seen play out in my world over the last several weeks around this crisis we've had in the family. Some really intense dramas that to me seem to have their roots in perspective and perception, and specifically either the inability or the unwillingness to see what is unseen, to look at what the other person's perspective, to understand where they're coming from. Instead of going to judgment and blame and they're a bad person because they don't see it the way I see it. And of course, death intensifies all of these emotions. Instead of seeing it that way, if we could stop for a moment and say, what has that person's experience been? How has their life shaped them? You know, how did their, and I'm not talking about getting too analytical about it, but what has this person had any life experience that has qualified him or her to see this as you see it? What is the commonality in their experience? Or are they coming from a completely different angle? And could there be value in that angle? Does it have to be one way? Is there a right and wrong? And I'm seeing all of this conflict come out of that, but the conflict is also, I think I could say always, an invitation for synthesis. If we pause and consider the unseen portion, what is it I'm not seeing? This has become so big for me with my teenagers as they're getting older, because they're changing, they're mutating, they're adapting, they're growing, they're emerging into their own adulthood. And I can't, as a parent, be successful with them if I'm keeping them stuck in my own expectations in their childhood state. I have to let them become who and what they are and keep up to that evolution and see the world as they're seeing it, whether or not I agree with the world they're living in. And boy, am I seeing all kinds of examples of how maybe I am the dinosaur because they do not live in the same world I did at their age. They just don't. And that's an important perspective. So the value of the unseen portion, as Susan, I think, intimated a minute ago, actually thinking consciously in terms of there is a part of this I'm not seeing. What is it? What does it mean? How
Well, and this could
feel?
And this also comes back to ideas of boundaries as well, right? What you're not seeing and what you're not seeing and what you do see, and there's limits for what you do see. You can start to understand where change can occur. That's an important point if you're talking about organizational design. So just take, for instance, you're taking perspectives of what would, from your perspective, be optimal. But then there's the reality of what is actually possible, because the client will only allow you to do so much. So understanding that, you're learning to work within the boundaries, not just your perspective.
Over which you don't.
And so, exactly. And that's how you make connections, real connections that are actually able to make differences. Because the reality is, if you come in with an optimization and people are not they're not going to enjoy being told what to do in teenage organizations or anything else like that. So that's the important part. What this is the physics behind all of that. And the behavioral aspects of it they're starting to, obviously there's behavioral economics and things like that play into this. But nonetheless, this is critically important to understand. And it also is critically important to understand in the sense that how not only we perceive things, but how we learn. And so this also relates to, this has a relationship, I don't want to go into it, but this does have a relationship into I guess all right, quantum physics, I was going to say. All right, but it is space time, and it does, but I'm not ready to go there yet. Has a direct relationship to that. I have to watch a few more videos on that in order to be able to explain that clearly.
I like the behavioral tie-in. Thanks, Joe, for that
Yeah.
input. Manu, you're
Yeah.
jumping in your seat. What's up?
No, I was saying that from all of this, one of the things that really, really marked me in terms of behavior also is that you have to be humble.
Mm-hmm.
Yes.
Recognizing that what you know, that is what you see or what you have experienced, is very tiny in relation to what it is. Imagine that what we knew was bigger than what is not known. What will happen? Life will stop.
Mm-hmm.
Because we wouldn't have that veritas anymore. It will just shrink,
Right.
shrink. So it is very important to realize and to be humble enough to say that what you are seeing, what you experience is just from a certain point of view, from a certain reference of something that has turned, twist, evolved in a very complex way. And it comes to what Wayne was saying, is the consequence of that is to be open to the other point of view because it was hidden from you. The other consequence of that is what Ray Dalio called, I think he called it intelligent disagreement. What does he call it? You remember? You know, it say,
No,
you disagreeing with somebody, not in a very subjective way, but in objective ways. That is, you sincerely bring forth your argument, the other person sincerely bring forth the argument, and maybe in the end, the two of you concede and that experience tells you, or an arbiter or somebody else.
Wasn't that a beautiful trait of Bucky's, though, that with all of his knowledge, which even now we're learning is ever more profound for that time, to know all that he knew with the tools that he had and the time that he lived, it's just a phenomenon in and of itself. And yet he had that beautiful childlike humility. He had that constant eye on how vast that was and how small he is. I've got a business card holder over here. It says, "Oh God, my boat is so small and your sea is so vast." And that's kind of the point, you know, that no matter how much we learn in this life, we still have just a minuscule understanding of all that's going on. And that's true in every interaction with every person and every relationship. And if we approach it from that point, instead of from this arrogant, I've got the answer and you'll march according to my drum, there's going to be a lot more peace on the planet, and we'll get to solutions a lot quicker because of the collaboration that you're talking about now, Manu. Here's how I see it, and here's what I think, and here are my values. How do you see it, and what are your values, and where are you coming from, and what is the highest good we could do together? What parts do we put together?
And I'm going to just pop in on the sociability piece of this. I think it used to be called civility, that there were people of good conscience, and you could start with that premise.
Yes.
That we are here to explore our disagreements, but I'm going to start by agreeing that you have a good conscience, that you have some personal integrity, and that what you bring is valuable, even if I don't agree. If I'm not going to move, I'm not agreeing ahead of time that I'm going to change my perspective, but I'm going to agree at the start that I believe you have integrity and what you are going to bring to this conversation is meaningful. And when we have this exaggerated polarity in our society, there is an invitation by grunge to not allow for that discourse. All the censorship that just happened in the scientific community, that got blown up so that we could see just how many constraints there were on civil discourse.
Yeah.
It's just profound. I do think that I would love to see that the critical mass develops by the folks that are saying no to the artificial polarities.
I could share an interview. It's a CNN interview with Arnold Schwarzenegger that I saw this week. It's very short. It's only about 8 minutes, but he was interviewed, and he's a Republican and a politician, governor of California. And he was talking about the polarity. He was talking about the lack of civility. He was talking about this, everybody is hating something, and it's this against that, and color, white against color, and male against female, and on and on and on. And he said, that's what concerns me. He said, it's not Trump or this or that. It's not the personality. It's the polarity, and it's the combativeness of it. Because he said, that's exactly what I saw in post-World War II Europe. He said, my father was a Nazi. And that's what I saw in my home as he tried to hold on to those ideologies that caused so much trouble in the war. And of course, Arnold segregated himself and stepped away from that and said, no way, I'm not part of that. Which takes a lot of courage on his part politically nowadays to even say those words. He could get hung himself, but he's courageous enough to do it. So yeah, I agree.
Lots of other boundaries too, and survive.
Yeah. So how important to the saving of spaceship Earth is the thing that we're talking about right now? How important is it to have a willingness to see what is unseen and to invite discourse and open up? And I think we do that every week on this call. I mean, there are things that you guys sometimes say that hit me as very abrasive. And I get to look at that every time it happens, say, okay, what is it in me that is causing that kind of reaction? And what is there that I can learn here? And when I bite my tongue and hold off and listen better and allow time and space to have the dialogue, we always get through it. We always get through it to what is for me a better place.
I mean, yeah, I mean, I don't want to go too far off topic, but for me, this humility and this unseen is the reason why you rely on generalized principles.
Yes.
And that has profound implications. Because that's where, when we say veritas, virtue and virtue ethics is more, to me, more important than a deontological or utilitarian way to look at the world. So, because both of those, you are assuming you have the answers, and so that's very dangerous not to rely on principles versus the idea, versus relying on simply quantification. And this is incorporating the unseen, which automatically means that you need to rely on something bigger than yourself.
There was probably a time in my life as a 20-something-year-old that I started this journey grabbing for all the knowledge I could get about money. And, I wanted to have money and I wanted to be rich, so to speak. And I was attracted by that kind of a message. And of course, I have that whole history with the Rich Dad organization, which I find that message more and more at the core of that. I've been receiving tweets from Robert, and I'm finding myself less and less aligned with his position on almost anything. Because at the core of that message I hear, and I don't mean to be critical of him, maybe I am, but that's not where I'm coming from. At the core of the message as I perceive it is getting rich is everything. Get rich, get rich, get rich. Money, money, money. And I just don't align with that, because I've lost faith that can solve our problems individually or collectively. And so what did you say? The virtue of ethics? What did you say a minute ago, Joe? What was that term?
So it's virtue ethics, essentially, so that you're relying more on principles than you are actually on your perception of reality.
Yes.
So
the principles
and
are
essentially, yeah.
they're boilerplate, they're engineered in, they're structural, they're forever. Because they're generalized, they will apply in all situations if we dig deep enough. And even if we don't understand them perfectly, if we make an honest attempt to build our lives around that and to operate from there, I believe it's going to see us through, because it's the only thing that's structural. It is the tetrahedron versus the square. It is.
Yes,
the
it is.
structure.
Yeah, it's
That might have been poorly stated.
yes. No, it was stated very well.
The tetrahedron is the what, Wayne?
It is the stable structure and the square is unstable.
Cube. Tetrahedron, cube, triangle, square. Triangles and squares are two-dimensional.
Yeah.
Tetrahedron and cubes are
So you have to
three-dimensional.
relate the cube to, right? Yeah, good point. So the triangle is more stable than the square, or the tetrahedron is more stable than the cube. And I think we're at a point in our evolution we get to choose and see, how can I even have the thought in my mind of choosing between a stable structure and an unstable structure in today's environment without stepping out of three-dimensional reality, without going beyond myself into a bigger thought form. You know, that's part of the value of these conversations, is the way it relates metaphysically. I still don't have a full conceptual understanding of how the geometry is formed at the energetic level. I know it's there. I see it in the bonding. I think I almost have it, but it's still difficult for me when I think of spirit coming into matter through that geometry that I just demonstrated. What's it called? The octahedron? Is that what that is? A decahedron?
Icosahedron.
Equilibrium.
Icosahedron. Yeah, it's the cube octahedron or a vector equilibrium, like Susan said. It's a cube octahedron.
right.
This is a cube octahedron?
No, the
This is a-
Jibberlug is a cube octahedron. Oh,
This
that
is-
is a cube octahedron. Yeah, that looks like a
Okay.
cube octahedron to me.
Okay, so if that's what we're calling it, then I get this. When I look at it structurally like this, I'm still not quite the point that I'm seeing that in my mind's eye operate energetically out there. I trust it's there. I believe it's there. I'm just not quite able to see it in my mind. But my point is this: how without this call for the last 12 years, how without these conversations, how without the study, how without Bucky, Manu, Susan, Steve, Joe, could I grasp this? Where else would I go to get this? I had somebody say to me the other day, well, yeah, insight into the source, but I don't think I would have gotten there on my own. I surely wouldn't have gotten there as fast, maybe not in this lifetime. I mean, I've learned more about mathematics on this call in the last 6 months than I've learned in my whole life in school. And they're functional mathematics, and that's extremely valuable to me. So I like coming together, and it seems to be collapsing into structural understanding that we can put to use on a day-to-day basis, even beyond the level of mere application in a real estate formula. This is application at the values level, which I find to be extremely exciting.
So I just looked something up where it says at 90-degree duality occurs with the electric and magnetic fields.
Absolutely correct.
So radiation and magnetism at a 90 degrees, is that what we're saying?
Electricity
Yep.
and magnetism.
Well, isn't electricity radiation?
It's
So is magnetism.
magnetism is also radiation, as Susan says.
My-
Electricity and magnetism creates electromagnetism.
Which is what?
They're all radiation.
Well, it's so at the very high.
Electromagnetism.
So but let's just go to a very high level for a moment. Is that it's the relationships between two systems
At 90 degrees.
at 90 degrees.
Mhm.
Yeah, and that's where all this comes out of. But you just lost me a minute ago. There are two forces,
But
in the
the
universe, right? Radiation and magnetism.
No,
Two main forces.
No.
radiation
Electric
and
and-
compression are the dual. Electro and magnetic are a dual.
right.
So electricity moves in radiation
Out.
and magnetism also radiates. So it's getting
That's
clear about what radiation is.
Thought
Radiation is movement out
magnetism
from
draws
center.
in.
That's gravitation. This is radiation.
Okay, this is the way it is. Wait.
Let me do.
These are 2 pens, eh?
Yeah.
One, the yellow pen is electrical, and the black pen is magnetic. If I put the two together like this, each is always flowing to wherever it's going. That's what they do in the core. Okay, but look at this. Coexisting means embracing, right? To coexist means to embrace, mean that even though I might be opposed to you, we still live together. Now, what is to embrace here? Look at it. This is embracing, is a cross. This is to embrace. If I want to embrace a fellow human, I don't embrace him by like this. The human plan is like vertical. It is high in vertical, more than girth. So to embrace him, I open my arms and I wrap him around. You say that we are embracing. That's what electrical and magnetic do to form a tetrahedron.
And
Two dimension, dimension coming together like this.
but
There it
so
is.
so that's it. That I mean, we've covered that. But
Yes.
And do you see that it's a torus?
but
Do you see that it's
yes,
a torus?
but
It's a
Yes.
torus radiating torus, electricity and magnetism, both radiation.
Yeah, guys, I'll have to study
but
this.
one
We're too late. in the
but
call.
there's a very I just one point I just want to
Yeah,
make.
please,
that
Joe.
I
I'm
think
not trying to
that's-
cut you off. I'm just saying I apologize for throwing this on the table.
No. Well, no. This is critical because this is what you taught me, Wayne. Remember the law of attraction?
Mm-hmm.
How we talked about magnetism
Yes.
and as a principle? That's what this is essentially. You know, electric and magnetic fields coming together, but it's the same thing that exists in our relationships.
I get that portion of
So-
it. I need to rethink it because I think I'm superimposing radiation in there somewhere.
No, so if you grab my chat, Wayne, what you're getting at is the exact tensegrity. So radiation starts at the center and moves out. Gravitation starts out and pulls in. Magnetism is that attractive force, it's gravitation, and it exists in duality, necessary for each other with the force of radiation out. So we typically, from our perspective, describe electrical radiation and magnetic gravitation. We just don't always use those definitions as clearly as they could be, but they're a dual, they are in tensegrity with each other.
Yeah, I get
Does that
that.
help?
I think I'm almost there because they always embrace at a 90-degree angle, correct?
Right, so it's the pressure out and the pressure in, and they're both happening at the same time, and they're creating a shape when they do it.
Yes. Yes. Another thing, Wayne, the experiment, if you take a stick, right?
Yeah.
You take a stick and then you put a stick that is, like iron rod like this. It is neutral. in terms of magnetism. Now, if you wrap around a conductor, let's say a wire like this, around it, you call it a solenoid, right? So if you put a direct current at one end, that current is going to circulate in doing this. If you put now something magnetic, some metal, you're going to see how now it's being moved that way. Your current was going like this in a plane, like a disc.
Yeah.
But the magnetism is going to play like this. It's going to attract,
pulls it
push
at
it, attract. Yes, yes. That is an experiment that your son probably, in elementary school they do in class.
Yeah.
They call it the solenoid experiment.
Everybody look at Steve. You're about to see pure joy.
The smart pen, the 4-dimensional pen.
Steve is known
Yeah.
for pens. I got this from Steve. I've got a couple of them. I got them years ago. I still have them. This is his favorite pen.
I give them away everywhere I go.
Excellent.
And Kelly used to use those 4 colors to diagram just about everything.
Yeah,
So you would try and get that sensation of
right.
the structural components.
Black,
necessary
blue,
structure.
green, red. Those were
That's
its
it.
colors. Black, blue, green, red.
All right, guys, we're at wrap time.
It is at wrap time. So, Manu, how are you feeling and what's your takeaway?
I'm humbled, really, by our openness here to share without fear of being shamed what is coming out of our mouth. It might sometimes be bullshit, but it helps. And I have the impression today that, we as a group have progressed into some understanding of what Susan usually called datum. And that will help in the future. And I also like to be cognizant that I think it is simpler. It might be simpler, possible to simply describe things in a way that are very, how will I call it? Tactile, let's put it. Very complex in a way, tactile way, in such a way that we can visualize in our world what it means at least, and we can understand it to position ourselves. I think that we get into a very important concept today from Wayne's question, where we are in that universe and it's a game of positioning because energy is going around through whatever without caring from your position. It's for you through your intellect and your agility, that is your physical, to use those to maximally position yourself in such a way that you are useful to the largest extent to the most people. That's what I get from this. And otherwise, I wish you all a further very productive and very joyful week. So, Joe, how do you feel? What do you take away?
I feel very, very good and very fortunate. I was just listening and kind of taking in different things as people were talking, and I appreciate you allowing me to do that because that allows me to think about these things a little bit more deeply. And when I walk away, I'm starting to see the mathematics behind some of the ideas that I've been thinking about, or understanding how duality works is kind of critical to understanding how humans interact. And I think that that's where you start to see how science works together, where electric and magnetic fields work together, but also how that relates to our everyday experiences. So that, going over this really is beneficial for me in a number of ways. The polynomial and its relationship to the tetrahedron in the 4D experience is something that I need to work on. That is, I think that's the next step for me, and I look forward to exploring that in the future. I also appreciated revisiting the imaginary numbers as well. So, that's something that the more you go over it, the more it starts to make sense. So, those are my main takeaways. Ultimately, it is gratitude for allowing me to be here. And as these concepts become more clear, I think that I'll be able to make connections, not even on a human level, but also on a mathematical level. And I think that's critical to my personal development as a human being. So it's good. I love the mathematics because it gets me outside of my comfort zone. And if I master the mathematics, not master, that's a little bit, that's an overstatement. But if I know enough about the mathematics to articulate the ideas clearly, just as Susan just did with electric, with the electric and magnetic fields, or the way Manu does for us, then I'll be choosing my words much more carefully. So that would that's where I see this actually helping me, because once you can actually explain those concepts with some precision, you're actually thinking a little bit more clearly. So I think that this exercise is very helpful for me. It's more than an exercise, it's a philosophy. It also reinforces some of my philosophical beliefs as well. So with that, Susan, how do you feel? What are you taking away from today?
Well, I am delighted that everybody was willing to stay at a point and really work towards some more clarity. I think we made some real dents into the idea of what is topology. I am appreciative that from Manu's really hammering that duality is not opposites. The two parts of the duality are necessary for each other's creation. They must exist at the same time. And for the first time, I started to get a sense of Euler's identity. And I need to go back and spend some time there. But the whole idea of studying Bucky is to look at the geometry of thought and to also not be scared by the word geometry, to be invited to those relationships. And I know that I'm probably kind of a little out there. I love just, that image of the Dos Equis man saying, "Stay curious, my friend." And during that little time that I took away from work to go visit with my boyfriend, I started watching Ted Lasso, which is on Apple TV, and think that you might all really enjoy it. So it's this American football coach that comes over to coach a British premier soccer team. And this guy has a perspective that's just refreshing and positive and looks like it's stupid in comparison to all these, very razor sharp other people. And he was relating, he always tends to go into a story to help people kind of see where he's coming from. And he's in this dart game and he says, when I was younger, there was this bully. And so I used to get bullied a lot. And I just realized that they weren't curious, because if they were curious, they might ask things like, have you ever played darts before? What hand do you throw with? And he said, because he had started out just kind of chucking a couple darts with his right hand, you know, hitting the board, but And then he goes, yep, for every Sunday for 10 years, I would go with my father and play darts. He goes, turns out I'm better left-handed. Poof. And just this idea, like, if we come up against these abrasive and highly emotionally charged situations, and we would take the moment, instead of feeling threatened, instead of letting our IQ go down as our emotions went up, if we would take that moment to shift out and observe from another perspective and ask questions, get curious, we might see a whole lot more. And that's why I've always been truly, truly amazed at this invitation to appreciating the geometry of thought. And as we were seeing with the electromagnetic fields, motion is necessary. And motion is necessary for precession. My perception starts to intersect with whatever motion's going on. And I want to get to expand what it is I can perceive. Wayne, how are you feeling? What are you taking away?
Susan, was that reference to the soccer coach a movie?
It's an Apple TV series, which is ridiculously fun, but heartwarming.
If you could send me a link on that, I'd appreciate it. I'd like to watch that with Preston since soccer's his sport.
Oh my gosh, you got 3 seasons of binging coming up.
All right.
Mm-hmm.
Well, thank you. I feel subdued in a good way. I feel humbled by the call this morning. I honestly, guys, I constantly find myself reaching into a realm that I feel I'm unqualified to track with all of you on. And it's wonderful that you allow me to be here in spite of that. And I sometimes am concerned that I don't have as much to contribute as many of the rest of you do on that scientific plane. But what I really love about what's happening, at least as I perceive it, is there's a word that I really adore, at least at this point in my life. That word is coalescence. To coalesce. It's such a beautiful word energetically, and it speaks to me of things coming together and blossoming out of and condensing and taking on additional meaning and important density. And so I feel a coalescence on this call. I feel like we've had all of these strings of ideas and thoughts and theories and truths and formulae and whatever else that have been floating around out there, and we're tugging at all these strings, and all of a sudden we're knitting something out of it. And the tapestry is taking on some form and some beauty and some artistry. And that's exciting to me, because I really am driven to what does it mean and how do I apply it? And how can it make the world a better place? So I'm extremely excited that we seem to be on the threshold of that, and even crossing that threshold and starting to make it a part of our everyday reality in many more important ways, if only conceptually right now in some of those ways. So thanks for all your contributions there. And the experience I'm having today is that I hope I can find time to grab a hold of some of these things I've thought and seen today and lock them down, because I'm concerned they're getting away from me. I can't even record them fast enough and be part of the conversation here. That's why we get to go back to the videos, right? So it should be okay. So thank you all for everything today. And I will be studying hard this week and trying to get clear, especially first off on radiation versus gravity and magnetism and the relationship of all of those. Thank you for your comments, Susan, about the duality in that. I think that's all I have to say. Steve, how are you feeling, and what's your takeaway from this morning's call?
I'm just, I was quiet at the end of most of the end of this call, because I learned something strange. I took a class in transformational grammar and syntax. It was linguistics 457 or something. in my 6th year of education at BYU. And what I learned in that class was that when the teacher stopped teaching stuff, most of the students were pissed. They were returned missionaries who wanted to memorize the shit and put it on an exam and graduate. They thought it was going to be an easy class. And he stopped and said, well, the truth is we don't know anything about transformational grammar and syntax. Nothing has worked so far. This is about the time when Noam Chomsky and Marshall McLuhan were starting to blossom. They were starting to resolve some of these issues. He was totally frustrated as dean of the linguistics department. He put his feet up he put a sentence on the board. He runs, put his feet up on the desk and said, tell me what that is. And people were pissed. But what I discovered was I went into one of the most creative period of my lives. I wrote like 6 or 8 songs in that semester. And it was mind-boggling to me because I got to discover the universe, and that's what I saw happening today. I got to tell you, Wayne, I have not yet found a way to lock this stuff down. I've got to keep coming back to it over and over and over again from another perspective. And so if you can figure out a way to lock it down, teach that to me. I think the answer is to review these videos over and over again, review these concepts over and over again, have these conversations, and come at it from very many perspectives. I am so grateful for finding that 3D representation of imaginary numbers where he pulls that up. I have been looking for that every week for 4 weeks, and I have not been able to find it. And this morning I found it. Wow. And I'm so excited about that. I can't stand it. That representation, when the guy grabs the x-axis, twists everything around, and then pulls the x-axis up at 90 degrees to itself, and then we see that colorized ellipsis, 3-dimensional ellipsis. It's got to be some kind of, there's another name for it, I'm sure. It's an isotrope of something. Expand out of that 2D flat plane, bammo. That blows my mind. The video extrapolates or demonstrates the 3D nature of imaginary numbers, which have been expressed in 2 dimensions all this time. The way that science understands higher dimensions is collapsing them into lower dimensions so they can be perceived. And so, like Joe commented, from what I've understand from the videos I've watched, yes, quantum mechanics can be resolved without imaginary numbers, but imaginary numbers make it simple. You have to jump through huge loops to have quantum mechanics without imaginary numbers. And as soon as I have sine and cosine, bammo, quantum mechanics falls out of there. And I love this idea from my reference. What is it I'm not seeing? The goal is to see that which is unseen. The goal is to see that which is hidden. It's like I'm experiencing the triangle and everything inside that triangle 180 degrees. There are 1,080 degrees on that triangle. When Manu says there's much more that's not seen that is seen, I'm seeing 180 degrees. There are 1,080 degrees in that triangle, says Buckminster Fuller in Synergetics. My book, Extreme Mindfulness, is about stopping to see that which is otherwise unseen. How to see the space between the nows. So what is it that I'm seeing? That's all about angular perspective. It's all about stereographic perception. I'm going to show you some videos on stereographic perception, projection, which involves distortion. Like the tetrahedron is a metaphor of 4 90-degree angles, but it's expressed in 60-degree angles so I can conceptualize it. I had an epiphany today because I've been struggling with this. I've had to tear this sheet in order to create a 3D reality. I've had to tear it every day until today. And as I pondered the Hopf Fibration, I understand that to go from a 1 dimension to 2 dimensions, I fold to 90 degrees. To go from 2 dimensions, it has to double. It doubles. 180 degree with another 180 degree presents itself at a 90-degree relationship with itself. It doubled. Now I got to take this 2-dimensional reality and double it. In order to double this, and I've always had to tear the sheet, but I realized if I make one fold at 45 degrees right here, and then make another fold at 45 degrees right there, two 45-degree angles, blammo, I have a 3D reality. And, you know, I invite you all to take a piece of paper and see if you can take a one-dimensional plane and convert it into fold it into a 3D reality. It takes two 45-degree angles because I had to compress the angles. They're actually 290 degrees. It's 290 degrees to go from one plane, from one dimension to two, and I have to double that to get to three. So that was a big, huge epiphany for me. I'm so ever grateful. I no longer have to tear my pieces of paper to create a 3D cube. Okay, good. So, and the final thing I think is everything exists in a context. Generalized principles are a way to express the topology or the context or the values in which something exists. Topographical definitions are what is seen. Topological definitions express what is seen in the context of what is not seen. These are my epiphanies today.
Say that again, Steve.
I said
Topological.
topological definitions describe what is not seen, describe what is seen in the context of what is not seen. Topological definitions describe what is seen in the context of what is not seen.
Thank you.
Susan, would you send me your notes today, please, when you transcribe?
Sure. I'll be glad to. Susan, you
Me
want Susan's
too.
notes? Yeah, okay.
Susan.
Yeah, there might be some doodles. We'll see what you think.
Yeah, I've got my
I'll
notes.
take
I'll
them.
send them out. Geometry is just another word for relationships. Relationships and geometry are synonyms. That's what I got from Susan today, which is really cool. And the mathematical context are generalized principles, values, or topology. Generalized principles is topology. They're synonyms. Manu said, what is known is more than what is unknown is more than what is known. Yeah, a triangle is 180 degrees. It exists in 1080 degree context, of which 180 degrees are only part of it. So there's 900 degrees of reality unseen in a triangle of 180 degrees that is seen. This is synergetics. This is Bucky. The electromagnetic spectrum is a perfect metaphor of 90-degree relationships. All of electromagnetism is expressed in 90-degree relationships to itself. I showed you that video, the animation of these waves going along at 90 degrees to each other, but they are a 2D plane of a torus of precession that's actually occurring simultaneously, and I have to collapse these planes in order to comprehend them. A 3D tetrahedron exists in a 4D reality. Otherwise, there is no context in which a 3D tetrahedron or a cube can exist. You and I see reality in 3D. We actually exist in a 4D reality in order to perceive 3D. And 4D is is the context of the generalized principles in which a 3D thing. So today has been mind-blowing for me. I've loved listening to all of you talk. I've been taking notes at 90 miles an hour because everything you've said has been perfect for me. 9:05. Next week, we're going to look at stereographic projection because that's that's how we pull out that's how we project out this other thing. I'm so excited. I'm so delighted that you guys got something out of this today. And I'm so delighted I found that stupid video that I've been looking for. Go ahead, Joe. What did you say?
That electromagnetic video that did you put that in the chat?
I did.
I know you sent it out in the past. Okay.
It's in the chat, and I will attach it to the email that goes out.
Give me 1 second. Let me save the chat.
Did you notice that polygon is in a geometric context? The poly like x square things is in the algebraic context, describing the same things.
Yeah. We got
And
that.
that
when we looked up
degree,
the icosahedron.
degree is in the motion context describing the same thing?
Degree is in the motion context describing the same thing.
Yeah.
Gotta go, guys.
Degree has to do with angle, turning the angle.
Absolutely.
So in the motion, yes.
All right.
So you talk about degree of freedom.
Yeah.
You talk about dimension of a structure, graphic,
Right on.
and you talk about form of a topology.
We talk about Plato idealism
Cool,
and form.
guys. Perfect, guys. Cool. Bye.
Bye-bye, everybody. Woohoo!
Take care, everybody.
Yeah.
All right.
Thank
Steve,
you. Thank you for today.
Send us the recording. Maybe earlier. Can you do that? I would like to listen again.
I usually get it
Yeah, me
out.
too.
My goal is to get it out today.
Okay, excellent.
Cool.
Thank you.
Okay.
Bye-bye. Bye-bye, everybody.
Thank you.
Yes.